We will talk about programming of 8051 assembly language. And if I talk about 8051 microcontroller, I am talking absolutely about that. The assembly language is a low level programming language used for the write program code in terms of the mechanisms. Even though there are the many high intellectual that are the currently in demand, assembly programming language is popularly used in many applications. It can used for the direct hardware manipulation. It is also used for the write 8051 programming code. For the writing 8051 programming code efficiently with the less number of the clock cycle by consuming less memory compared to the other high level language. To understand the programming, you can see this is the assembly code, and these are the objective code. So if you want to write the assembly code in the programming language in the 8051, then you need to start with org00h move p0 hashtag 00h, then delay and the move fs assembler, and this assembler going to convert the objective code into the 8051 programming. 8051 programming assembly language is a fully hardware related programming language. So the embedded designer must have sufficient knowledge on the hardware of the particular processor or the controller before writing the program. The assembly language is developed by the Nomaki, therefore user cannot understand it, usually modify the program. If we talk about source file assembly, then assembler is there and linker is there for the executable file. Objective is there for the external file. So you can see the programming in assembly language. Assembly programming language is developed on the various compiler and the Keel vision means if you are using Keel software, then it's easy to write your software in the assembly language and making the file. The microprocessor and microcontroller are the processor can understand only binary language in the form of zeros and one. The assembler convert the assembly language to the binary language and they then store it in the microcontroller memory to perform the specific task. 8051 microcontroller architecture is the CISC based hardware architecture, and it has the peripheral like 32I0 timer counter, communication and memories. The microcontroller require program to perform the operation. They require a memory to saving and read the function. The 8051 microcontroller consists of the RAM and ROM memories to store the instruction. 4K byte ROM, 128 byte RAM, timer and counter, CPU, interrupters, input output port, serial bus. A register is the main part of the processor and microcontroller which is contained in the memory that provide a faster way to collecting the storing the data. The 8051 assembly language programming is based on the memory register. So if you want to manipulate the data to processor controller by the performing subtraction, addition, etc., we cannot do that directly in the memory, but it need to register the process to store the data. Microcontroller also contain the several type of the registers that can be classified according to their instruction to contain and operates in them. 8051 microcontroller program in assembly language. The assembly language is the made up of the element which all are used to write the program in the sequential manner. These follow the rules to write the programming in the assembly language. So what are the used to write the programming in the assembly language? The assembly code must be written in the uppercase letter. The label must be followed by the colon. All symbols and labels must begin with letter. All comments are typed in lowercase. The case last line in the program must be in directive. So these are the rules for the assembly language. The assembly code must be written in the uppercase letter. Label must be followed as a colon. Label all symbols or label must be begin with the letter. All comments are typed in the lowercase. The last line of the program must be end with the directive. The assembly language memory are in the form of opcode such as move, add, jump, and so on, which are used to perform the operations move A, B, opcode and operands. These are the operation code and these are the operands. So these are the these are the uh, operation code and these are the operands. If we talk about operation code, the opcode is a single instruction that can be executed by CPU. Here are the opcode in the move instruction. And then you have to operand. The operand are the single piece of the data that can be operated by the opcode. Example, multiplication operation is the perform in the operation that are multiplied by the operand. Syntax that use the multiplication a comma b. The element of an assembly language programming is assembler directive, instruction set, addressing nodes and modes. Assembler directive, the assembling directive gives us direction to CPU. The 8051 microcontroller consists of various kind of the assembly directives. Assembler directive, so assembler directive gives the direction to the CPU. The 8051 microcontroller consists of the various kind of the assembly directive to give the direction to the control unit. The most useful directives are like 8051 programming such as org, db. They are the directive and data eq, end. org is the origin, so the directive indicate the start of the program. This is the used to set the register address during the assembly. For example, org 00h tells the compiler all the subsequent code starting at the address 000h. If we talk about syntax, then you can see here this is the origin and it's starting from the initial point, like it's syntax you can see org 000h org 00h directive. This is the directive, so direction of the code and starting address of the memory. Now second one was our definitive byte. The definitive byte is to allow a string of the byte. For example, print the etgfc, wherein each character is taken by the address, and finally printing the string of the db directly with the double quote. Syntax org 00h move a hashtag 00h. Then db edg ttb string, then this is the directive, and print string. eq is equivalent, so the equivalent directive is used to equate address of the variable, and here is the syntax of the equivalent. A register equivalent 09 move resistance hashtag. Then end directive is used to indicate the end of the program. Here you can see the syntax register equation like a hashtag 0 move register hashtag 2h end. The way of the accessing data is called addressing mode. The CPU can access the data in different ways by the addressing mode. The 8051 microcontroller consists of the 5 addressing modes such as immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and base index addressing mode. Immediate addressing mode is the source must be value that can be followed by the hashtag, and destination must be SFR register, general purpose register, and address. It is the used to immediately storing the value of the memory register. Syntax move a hashtag 20s and slash slash a is an accumulator register where a 20 is stored in the a. Moving r0 hashtag 5, you can see these and learn it. In the stored in the 50 stored in the are registered, and it's likely the register to store in the. And then you can see the cx move r hashtag, then the final value stored in the r0. Then moving the r0 is the destination, and this is the source hashtag 20h. Register addressing mode. In the addressing mode, the source code destination must be registered but not general purpose registered, so the data is not moved within the general purpose bank registered. Syntax and x, then move a comma b. A is a first registered, b is general purpose registered. Move r0 comma r1, invalid instruction. gpr to gpr not possible. X move r0 and this one. Then you have indirect addressing mode. In the addressing mode, the source code of the destination must be indirect address but not the value. The addressing mode support the pointer concept. The pointer is variable that is used to store the address of the other variable. The pointer counter is only used for the R0 to R1 registered. You can see this syntax: move R0 hashtag 0 yes and equivalent value of the stored R0 registered and this is stored address to 08. Now indirect addressing mode, this is the best example to understanding the indirect addressing mode, like moving R0 comma hashtag 10, move R1 hashtag 08 and then address the variable and then the value. Base index addressing mode. So addressing mode is used to read the data from the external memory or ROM memory. All addressing mode cannot read the data from the code memory. The code must be read through the DPTR register. The DPTR is used to point the data in the code of external memory. Syntax that are the ADBT are the then memory and the central error instruction set and then microcontroller transfer instruction set, sequential instruction set, arithmetic instruction set, branching instruction set, loop, conditional, logical, boolean instruction set, arithmetic. These are the syntax. Conditional instruction syntax JPP10 label into syntax JBNBP1 label into syntax. Syntax, these are the GNC label in syntax, label in syntax, JNB label in call and jump instruction, JBOL label JNB syntax. These are the loop instruction, call and jump instruction and then loop instruction. Mnemonics description bytes, syntax area, shifting operator. So this shift operator are used for the sending and receiving the data efficiently. The 8051 microcontroller consists of 4 shift operator: RRRRC, rotate right through carry, rotate left through carry, rotate right syntax, rotate left